In this video, we're building a fully functional calculator, not just a design, right inside Figma using variables and interactions. No plugins, no code. Just Figma's built-in features like set variable, conditional logic, and prototype interactions to simulate real addition, subtraction, multiplication, and division. Let's dive into it. I already have the calculator design ready, so let's quickly look at how it's structured before we jump into the logic. I've designed just one component called key. Inside this single component, I've added all the buttons, numbers 0, 9, operators like addition, subtraction, multiplication, division, the equals button, and the clear button. You might be wondering, why not create two variants, one for numbers and one for operations, since everything's the same? And that's a great point. But here's what I found while testing. When I used variants for different key types and then connected them to variables, there was a noticeable delay in interactions. For example, pressing the number 1 wouldn't instantly update the result on screen. Sometimes it took about a second to reflect. That kind of lag can really affect the experience, especially for something like a calculator that's meant to feel instant. So instead of going with simple component, I built everything separate variant. That way, it stays fast and responsive, which is especially important for an interaction-heavy component like a calculator. I've created two states for the calculator key component. Default state, pressed state, to visually show the user that the button was clicked. Now in prototype mode, here's how I connected the interaction. When the user clicks a key, it navigates to the pressed state. Then from the pressed state, it navigates back to the default state when the mouse enters again. Now you might be thinking, shouldn't it be mouse leave instead of mouse enter? Ideally, yes, but here's why I chose mouse enter instead. After clicking a button, the cursor usually stays on the button for a split second. If we wait for a mouse leave trigger, there's often a slight delay before it resets to default, which feels a bit sluggish. But with mouse enter, it triggers instantly the next time the cursor re-enters the key, even if it's the same key. That way, the feedback feels snappy and responsive without requiring the user to move their cursor away completely. It's a small change, but it makes the calculator feel smoother and more real. Let's now jump into the variables section. This is where all the real magic happens. I've created a total of 21 variables and I've grouped them into 3 sections. 1. Operations. These are used to check which operator was clicked. It's stored as text. 2. Numbers. This includes all the digit keys, 0 to 9. 3. Temp folder, core logic. This is the most important section. Here's where all the real calculation data is stored. Temp total. This stores the final result after a calculation. Temp number, the number the user is currently typing. Operation, stores the last clicked operator. Second number and second option, check some conditions. Now that we've seen all the variables, let me show you how they're actually used inside the calculator UI. Every key in the calculator is linked directly to its matching variable. For example, the number 1 key isn't hard-coded, it pulls its label and value from the 1 variable. Same with all the other number buttons and operation buttons. Everything is dynamic and powered by variables. That way, when you press a button, Figma knows exactly which value to store and which interaction to trigger, making the prototype behave just like a real calculator. Now one exception here is the clear button. Unlike the other keys, the clear button isn't connected to any variable, and that's intentional. Because the clear action doesn't depend on any value, it just resets all the variables. So instead of pulling any label or condition, I simply hard-coded that button manually. Now let's take a look at the actual calculator UI I've designed. Every key you see on this calculator, it's built from one single component. In this calculator, the same area displays both the entered numbers and the final result. So I've added a variable called total, show those two. Now let's see how we wire up the number buttons. Select the number 1 key, go to prototype mode. You'll see it already has 1 interaction. On press, change to pressed state. Now click the plus icon to add a second interaction. Select condition. Select the variable 'no'. Set condition is equal to true, inside double quotes. Since this is not a Boolean, it's a text condition. Add variable, target as total, value, select total, then multiply 10 plus number 1. What's happening? Let's say the user just started typing. Total is currently 0. So 0 multiplied 10 is equal to 0. Then 0 plus 1 is equal to 1. Now the user presses 1 again. Now total 1. So 1 multiplied 10 is equal to 10. Then 10 plus 1 is equal to 11. And if the user presses another 1, 11 multiplied 10 is equal to 110. (110 plus 1 is equal to 111. This is where the magic happens. So instead of replacing the value each time, we append digits using math by shifting the digits left with multiply 10 and adding the new number. It's a small line of logic, but super powerful. Until now, we handled only the case where second number is true. If second number false, then target total and value as number 1. Here I'm not multiplied, just adding the number. Currently I set as true in variables section, but only one side that I make it as false. We'll show it later. For that, this condition added. Now we've handled both conditions. No matter what number we're typing, we need to store it in a common place so we can use it later during the calculation. We'll do that outside of the condition block. Another set variable. Target, temp number, value, total. So what we're doing here is, first we check the type of number we're entering. If it's the first, we update total number. If it's the second, we store the total number to another place called temp total. Why? Because later, when we perform the calculation, it's easier to use temp number as a consistent reference for the current input. Add a final set variable interaction from the same number key. Set variable, second number, value, true, with double quotes. Add another set variable, second option, value, false, with double quotes. Why this is important, that I maintain second number true and second option is false. Because this value is changing in place, that you will get once it is all finished. Before we wrap up the logic for the number keys, here's something super important to understand, especially if you're not adding interactions inside the main component. Interaction order in Figma. In Figma's prototype mode, interactions are triggered in the order they appear, top to bottom. If change to happens first, it will switch the variant immediately, and any interactions after that won't execute, especially conditional logic. What to do? So always make sure. Keep your change to action as the last interaction in the list. This ensures all your set variable and conditional logic runs first. Only then change the visual state. Note: if you're building this logic inside the main component, Figma handles it more gracefully because the component-level prototype interactions persist across variants. Now let's test how it's working so far. Click on the preview button from the top right corner. Click on the number 1. You can see that number 1 is immediately reflected in the display. That means all our logic is working correctly so far. The variables are updating, the condition is triggering, and the interface is responding in real time. Right now, we've set up logic only for number 1. We need to repeat the same steps for all other numbers, from 0 to 9. The logic is exactly the same, except for one small change. In the condition where we used total multiply 10 plus number, we just need to update number to match the key you're working with. Make sure you're selecting the correct variable, like 2, 3, 4, etc. Now, A quick but super important clarification. You might think we can just duplicate the interaction from number 1 and replace the value for other numbers, but that won't work in our case. Because each number key here is its own variant inside the component. That means every key, 1, 2, 3, up to 9, has a separate variable assigned to it. You cannot reuse the interaction from one key to another like a global setup. You'll need to manually add the interaction for each number key. If all numbers were in a single variant, this would be easier to handle with one shared logic. But here, using separate variants gives us more control and performance, especially avoiding UI delay issues in Figma. So yes, it's a bit of manual work, but it ensures smooth, responsive interactions without lag. Now let's continue and add logic for the next number. Now, I've finished setting up all the number keys with their own dedicated interactions and variables from 0 to 9. Let's jump into preview mode and test if everything is working properly. Click the preview button. Start clicking random number keys, for example, 1, 2, 3, 4. Watch the top display area. It should build the number in sequence like a real calculator. Tap 1 shows 1. Tap 2 now shows 12. Tap 3 now shows 123. And so on. Each number you press runs a condition. Total is equal to total multiply 10 plus pressed number. Awesome, everything's working as expected. Now we're ready to move to the operation logic like addition, subtraction, and equals. Before we dive into operations like addition or subtraction, let's handle the easier part, the clear button. This should reset everything and bring the calculator back to its initial state. When you click CA key clear, reset all the key variables. Total is equal to 0. Temp total is equal to 0. Temp number is equal to 0. Operation is equal to plus. Let's do one by one. Set variable select total and value as 0. Add another set, variable select temp total and value as 0. Add another set variable select operation and value select plus. Plus that we defined in variables section. As last change to option moved to his last item. Alright, I've wired up the clear button to reset all our variables. Jumping into preview mode, I'll press a few numbers first, 2, 4, 7. And now I hit the clear button, boom. It's reset. The display is cleared and we're back to the initial state. Just like a real calculator. So the clear functionality is working exactly as expected. Now that we've nailed down number input and reset logic, next up, let's handle the operation buttons, addition, subtraction, multiplication, and division. Let's start with the first operation, addition. We'll add logic to the plus button that helps us prepare the calculator to do math behind the scenes. Go to the Prototype tab. Click plus icon and select Condition. Select Variable, second option, Operator, equals value, true. Remember to put it inside double quotes. Then set Variable, select temp number value as 0. If second option is true, then we first clear temp number by setting it to 0. This resets the temporary storage for the second operand. After your first condition block is done, which resets temp number if needed, we now add a step outside the condition like this. Action. Set variable. Variable. Second option. Value. True, inside quotes. Right now, our second option variable is still false, but we're starting a new operation, so we update it to true manually. This helps future conditional checks know that an operation is now in progress. Now comes the core. We check which operation is active and do the actual calculation. Click the plus icon to add a new condition. operation is equals to, then select plus. In my variables panel, I created an operation variable called operation and plus, both the place I gave addition option default. Now go to prototype. Inside the condition, add variable action, set variable to set, temp total, value, temp total plus temp number. What's happening? If the operation is addition, we update temp total by adding the latest number we entered, stored in temp number. So if temp total 0, default value is 0 plus temp number becomes 25. After updating the internal temp total, we now show that result on the calculator screen using the total variable, the one that's connected to the display UI. Let's display this on the calculator. I'll add another action to set total temp total. This will update the calculator screen with the result of the addition. So every time press an operator like plus, we store the input in temp number, add it to temp total if the operation matches, and finally display that result by assigning it to total. Now that our current result is stored and displayed, I'm setting the operation variable to addition. The operation variable controls what kind of math happens: add, subtract, multiply, divide. By default is addition, but now we're preparing the calculator for the next input in calculation. And finally, I'll reset second number to false. That means our calculator is now ready to accept the next number from scratch. Last change to option, drag to down. Let's test our calculator in action. I'll click 3 phi, then the plus button, then 5. Now when I press plus, boom, it returns 8. That means our variable logic is working exactly as expected. On not configured equals yet, that will add as last option. Now let's set up subtraction. It's exactly like addition, except instead of adding the numbers, we're subtracting them using the temp total minus temp number logic. Let's see how it works. Let's set up the subtraction function. Just like addition, we'll first check second option if yes. We'll reset the temp number to 0. Then, add another set variable outside condition logic. And select temp option value as true. Next, let's add a new condition for the minus operation. Select operation, check if it's equal to minuses, and if that's true, we'll subtract the current number from the total by setting temp total to temp total minus temp number. Next total to temp total. Same logic that I applied for addition. Only change, I select minuses option instead of plus. Then, we'll update the operation to minus so it's ready for the next calculation, and set twin number back to false. Finally, don't forget to drag the change to action to the bottom. This ensures all our variable logic runs before switching the button state. Now let's test. I'll press 9, then minus, and then 3. The correct answer should be 6, but here it's showing -3. That means our logic isn't working as expected. If we look closely, we followed the same steps as addition, but here's the issue. In the variables panel, the default operation is still set to addition. We're updating the operation to subtraction at the end, so during calculation, it still thinks it's adding. Let's fix this. To fix the logic, I'm selecting the condition that checks the operation and create another condition. Now it is duplicated. Now we have two identical blocks. In the first one, I'll change the condition from -2+. And in set variable also temp total plus temp number. This way, each operation will have its own dedicated logic block, and the calculation will run based on the correct operation at the right time. Let's test again 9 minus 3, and yes, we get 6. Perfect. It's working as expected. Now we'll apply the same logic structure to the addition function as well using separate condition block. For each operation, whether it's addition, subtraction, multiplication, or division, we need to check what the current operation is and calculate accordingly. That means, for every operator button, we need to create 4 separate condition blocks. One for addition, one for subtraction, one for multiplication, and one for division. Each condition will check the current operation and run the matching calculation logic. And for multiplication and division, it's exactly the same. Just change the operator and update the calculation formula. No other changes are needed. Now I've set up the same logic for all 4 operation buttons, that you can see all the operation buttons are updated. Let's test. Addition is working. Subtraction is working. Multiplication is working. And division is also working as expected. The only thing left is the equal to button. That's not configured yet, so let's set it up now. For the equal button, we're going to reuse the same logic we applied in the operation buttons. We'll check which operation is active, then calculate using the stored values. The only difference with the equal button is that we're not changing the operation. Instead, we'll use a fallback option called temp. If the operation is equal to temp, then we update temp number with the value from temp total. This ensures our calculation completes correctly. Finally, we set one number to true and make sure this change to logic block appears last in the interaction order, otherwise the flow may break. One last thing in our operation buttons, like addition to divide, we haven't yet handled the scenario where the current operation is already temp. This is important when you press multiple operators in a row. Go to the addition buttons. Click plus to add a new condition from operation stack. Condition: if operation equal to temp, then set temp total equal to temp number. Drag this condition above the existing operation logic. Let's make sure the final logic is consistent across all operations: addition, subtraction, multiplication, and division. Now let's test try. 5 plus 3 equal to, then press multiply 2 equal to it should give you 16, just like a real calculator. It's working perfectly. Now we have a fully working logic-based calculator in Figma using variables and smart prototyping. For your reference, I've published the file to the Figma community. Feel free to duplicate it and try it out yourself. And that's it. You just built a fully working calculator inside Figma with real logic, dynamic input, and operation-based results, all without a single line of code. Whether you're a designer looking to create smarter prototypes or just curious about what's possible in Figma, I hope this helps spark some ideas. If you found this useful, don't forget to like the video, subscribe to the channel, and share it with your design buddies. Your support keeps this channel growing and helps me create more in-depth Figma content like this. Thanks for watching, and I'll see you in the next one.